Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the microcontroller lectures. After we discussed about the concept of GPIO in the last lectures, episode 3, now in episode 4, we will talk about the application examples, also live coding using our micro C compiler and also using our simulator software, which is PixSimulate. So this is the diagram block of the PixSimulate on the fourth of the board in the PixSimulate, the Genius, which is we will give you an example about the simple port I/O applications using the LEDs that is already connected to the port P and also to the port D. There are each of this port provide 8 LEDs, all the red colors, in the red colors. Also on the port D, it's also 8 LEDs, all in the red colors. So this is the circuit according to the connection between the LEDs from the port B and the LED from the port D that we have discussed this in the last lectures. So we go to the next slide that for the assumption that you have installed the micro C compiler. So for the first time, you need to click the new project right here. Here, there are new project, and open example folders. But if you want to make a new project, then you can click the new projects button here or icon here. So the next step is to write your name of the project. It's up to you. And where is it? Where do you want to save the projects? And don't forget the device name is PIC60F877A. So you can click here and you can choose the PIC16F877A microcontroller, and the device clock is 8 megahertz. Or you can change the device clock according to the simulator maybe or the real hardware. Okay, it's up to you. Then you can click the next, and then you can, I think, just click finish. Okay, just click finish. But if you've already have a file, maybe from some of the website, like providing you the files from the application, so you can add the file. But from now, we will we will make the C file to our application. So I think you don't have to add, you don't have to click the add button, but you have to click the finish button. After that, you can click in the main windows, in the main program windows, uh, the program like this. Okay, just take a look. I don't want to talk about the sing language itself, but please pay attention because we want to try to make some LEDs on and to make some LEDs off in the port P and also in the port D. So I have write the code just like this. Okay, from the first trace is all zero. The trace all zero, or you can write 0x00 in the hexadecimal format. So you can write with the binary format like this, or you can write in the hexadecimal. Also in the 3D, I write the code with the hexadecimal format, but you can try this with the binary format just like this. All zero, it means that all the part of the port T is all outputs. The direction is output from the microcontroller going out, okay? From the microcontroller going out. That's the mean of the zero value in the each of bit. So this is the 3-space. It means that all the port P and all the port T is output direction. So it can drive the LEDs and so on. Next, after we configure the port P and port T with the register 3SP and 3D, you can write your logic here. 0 it means the LED off, 1 it means the LED on. Okay, so it means this for the port P, it means that off, on, off, on, off, on, off, on. And also for the port D, if you can see the binary port is on, off, on, off, on, off, on, off. The number is AA. Okay, A is according to the decimal 10. Okay, so maybe some of you have a question, which is, can I write all the trees before the port? Yes, you can. You can write all the 3SP and 3D for the first, and then you can try to type your command here, port P and port T. But in my case, or in my program, I read 3SP and then port P, 3D and port T. But you can write 3SP, 3D and then port P, port T. It doesn't matter. Okay, so what about the result? You can compile this. I give you an example using live coding. Just a minute. So this is my program. So you can build here, build, or Control F9, build. Okay, so there no error. Alhamdulillah, no error. And then you can you have a hex file. So we need to go to the simulator here, file, load hex, and this is our hexa. Okay, open. So this is the result from the Pixim Lab. Just remember, you have to switch down. Okay, switch down the deep switch right here. Okay, switch down the deep switch right here. Okay, so this is you have to switch down the deep switch right here, and the result is just like in our program. Okay, that's the first example. The second example, just like this, I give you okay, the zoom one. Maybe okay. We are going to display combination of LEDs using the port P. Okay, it doesn't matter. Okay, so you can write the port P 3SP, the port P first or the 3SP, but I recommended that you have to write 3SP first and port P then. So the 3SP is 0. So all the port of P is going out, output direction. And the port is P is FF. All LED is on. So we need to delay ms, this millisecond. 1000 is 1 second. Delay for 1 second. Sorry, this is still in Indonesia. And then port P is going off. Okay. Now, okay, for K 1 to 20, so this loop is 20 times. Okay, switch port P. Okay, switch port P. This is some of the C language. If the port P is 00, then the port P is if the port P is all off, okay, or 00, then we need to turn on using FF. And then delay 100 millisecond. Break is going out from the switch. Okay, and then for the second round, the case for the port P is FF, okay? Before it is 00 and then FF, and now the second round is FF. Then the port P is 00, delay MS 500. Okay, so off is more short than the, sorry, on the LED is more short than the LED is off. 20 times, okay, 20 times, and so on and so on and so on. Blink with this kind of the code, and then we need to make combination before blink all the LEDs in the port P with this combination 01 01 01 01 01. Okay, so the port P is not of the previous port P. This kind it means the negation or not. The port P now is not port P previously. Okay, the current port P is the not or the negation of the previously port P, and then delay MS. So what we have here, the first time we have 20 rounds, 20 times of this kind of link. Okay, all on, all off, on off, on off. Okay, and then for the transition we need to, okay, just for the transition we need to make it combination of LED on or off, just like this. And then we need to something like this because the toggle is after 01 01 01 01. After this port P equal to negation of the port P is then 10 10 10 10 10. So this program will be blink the LEDs. The first button is on the LED, but the second button is toggle between LEDs. Okay, so this is the, okay, now let's see something like this. Okay, all the LEDs on and then off, on, off, on, off, and this is the first combination and then the second combination. Okay, it's a simple. Okay, let's see in the PixSimLab. We need to load the hex. I already compiled the program. Okay, this is all the LEDs 20 times, and then the last of our program is toggling the blip like this. Okay, just nice application. Okay, just remember this is a simple application to help you understand of the GPIO concepts. Okay, the next one is animation. So the animation is just like this: 1 2 4 8 10 1 20 48 in the hexadecimal C E F F8 FC FA FF F0. So the program is like this. Okay, we can use the array, and the name of array is tab, TAB. We have a 16 index, so we need also the 16 index using this. Y is equal 0 if y is more than 15. So from 0 to 15. Okay, that's a 16 combination. You can, okay, this is increment the y itself. So the port is type y. So the first time is 0. So the LED is on according to this pattern. Okay, before the seventh segment, I'll show you the result of the third program. Okay. Okay, this is like this. Okay, it's nice. This the animation just I mentioned before. Okay, that's the third programs. And the next program is according to the seventh segment. I already explained this circuit before in the last lecture. and we need to have a pattern of number 1, 2, 3, 4, 5, 6, 7, 8, and number 0. So if you want to display the number 1 in the 7 segment, you have to send the data like this. Okay. Oh, sorry, this is for the 0, and you have to send the data like this. So this is 1, 1, 1, 1, 1, 1. Okay, 1, all 1. But for the number 1 is only 2 letters here according to the RT1 and RT2. The 7 segment is uh, according to the A, yeah? A, B, C, D, E, F, G. Okay, so 1, 1 is PC. PC, this is PC. So this the 8, number 8 is all 1. Okay, 1, all this one. Okay, so we want to play to try, because the 7 segment is in trace A and trace D. The trace A is for the display, and the trace D is for the 7 segment data. So we need 1, 1, 1. So 111 is number 7. Okay, 111 is number 7. Okay, so we need to the first digit. Okay, so the first digit. Okay, according to that, the first digit. Sorry, this the fourth. Yeah, the fourth digit. So RA3, RA4, sorry, 2, 3, 4, 5. So the first digit is right here. This one. Okay. So this is the latch for the I mean the number, and this is, sorry, this is okay, display the counter at the first digit. Okay, this is I think we want to try this to the first program. Okay, this first program here. Okay, 66. Sorry, we need to. Okay, so what the program in this kind? We need to close first. So this is one. Okay, so sorry, I want to make it 0 here. So this is the 6, the pattern of the 6. Okay, I built. So this is only for the first display. Okay, so this is the first display. If you want to all the digit is on, so we need to make it 1, 1, and 1, just like that. And we need to build again. Okay, and then we need only to reload. Okay, reload hex. So all the display is 6 for all the display. Display 1, display 2, display 3, and display 4. Okay, so that's the, so we need to make it back 0, 0. Okay, and then reload. Okay, back to the original ones. Okay, so that's the first example of the 7 segment. And then this is the pattern from number of 0 to number of 9. Okay, so maybe we need to make a counter 1 digit using the first digit here, but the portlet you can use the FV. Okay, from 0 to 9, because we have only 10 memories of the 10 pattern of the number 0 to 9, and let port D is let and with, I think you have to with the delay of quarter of second to 215 milliseconds. Okay, so we need to go back here and load the hexa here. Okay, sorry. I think we need to turn off this, yeah. Okay. Okay, I think we need to, maybe we need to turn off this. Okay, so only one digit. Okay, and then we can reload. Okay, that's it. This is the data. Okay, this is the data. So you can turn off this, but I don't think it's necessary. But you can see the counter here: 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and so on. Okay, so that's the example of the one digit counter from 0 to 9. And the other, we need how to display maybe 0, 1, 2, 3 or 2011 at 4 segment. So just like the previous program, we have a LED character pattern for the 7 segment, but declaration for this 4 and this 4 alias according to its digit of 4 by 7 segment, and this is the declaration for 7 segment pattern displaying number 0 to 9. So this is the declaration. So we can use this declaration, this one, this one, rather than we need to access the statement like RE 2-bit, RE, it's so long and so boring. So we can define a symbol, or we can define a variable that represent of the constant of the bits. Okay, so just like this, like previous program, and then uh, we want to display one by one. Okay, because we cannot display all, maybe 1, 0, 1, 2, 3, all from the digit. So this is the first, activate the first digit, and then you can send the first data pattern, and then you turn off the first digit, and then turn on the second digit and send the third pattern, and so on, the fourth pattern, and the one pattern, second pattern, third pattern, and also fourth pattern. And you need to make a delay like this. You have to make a delay like this. Okay, so I cannot see the switch between one digit to the other digit. The eye see that all digit is all the on, just like this. Okay, this is the capture of the PIXSIM lab, but you can I will see you sorry, I will show you about the simulator itself. So this is 5. So this is 2021. I changed the program, so it's shown the 2021. So we need to change here is LED 2, LED 0, LED 2, and LED 1. Okay, that's it. So the next is counting all the 4 digits using PIXSIM. That's just like the previous code. This is the declaration of the this4 and the this1, and also the pattern display number from 0 to 9. So this is also the same. This is also the same, but we have to another delay for a while right here, and then we need to activate the first digit, which is 1000, using LED F divided by 1000. Okay, so the number is right here from 0 to 9999. So if 5000 divided by 5, F is 5. Okay, and then displaying 1000. This is displaying 100 using the statement like this, and this is the displaying tens using statement like this. This is the modulus then divided by 100, the modulus divided by tens. Okay, this is the for the watts f modulus by 10. Okay, that's the simple. So I'll give you maybe right here. Okay, this is the counter 20, 30, and so on until 9,999 and going 0k. Okay, so what about the LCD? The LCD is just like the others, because we have a library according to the Pixim Lab and also the Genius. What we have here is the library. Okay, so we have a LCD init, LCD command, LCD dot, and LCD SDR. So this is some of the command right here, configuration also, and this is the declaration is it's about the bit according to the circuit like this. So this is the LCD-VR, LCD command, and LCD dot. So just take a look at here. Lena is RA1 bit, L dot is RA2 bit, L port is port D. Okay. So len A, len dot, len A, len dot. This is LCD command, and this is the LCD dot. So this is LCD init. You have to call this first time at the first time of the program. This is to send the string right here. Okay. So this is from our test LCD. Okay, there is PA sini clear, going to first. Okay, going to first line of the Z because we have two lines here. Going to the second first, we need to display something right here. Okay, and then it's on some of the test. Okay, test LCD, and then some of the string. Okay, and so on. So this is the code txt to RAM txt. Example clear. Prepare your tip. Push the LP1. Okay, test LCD. Okay, and then just like this. Okay. So for the LCD is here. Okay. Sorry, this is in Indonesian. It means prepare your tip. Okay, it's already here. Prepare your tip, and then push RP1. This is RP1. Okay. Something like this. Write all the character to the LCD. So this is the minimum system that I mentioned before. You need to buy if you want to try in real hardware. You want to buy the hardware is like I suggest at the previous lecture, and I also you can you need to buy the development part because the development also the IC not playing like this. Okay, and the programmer maybe you can buy the PK 2 or PK 3. It doesn't matter. So this is the connection between the PK3 to the port. Okay, using the MCL1, PDD, VS, PKT4, PKC, unless the last connect. This is no connection. So this is connection standard debugger system to the port, and that's it for our lecture about the GPIO application example. If you have any question, please write in the comment below, and inshallah I'll give you the answer, or maybe we can discuss about this lecture in this below comment. Don't forget to like this video, and thank you very much for your attention. Terima kasih, mohon maaf. Assalamualaikum warahmatullahi wabarakatuh.